Hello guys, welcome to my channel. This is Karthik. In today's video, I am going to show the demo on VectorDB. Have you ever wondered how AI models find things that are similar, even when the words don't exactly match? That's the magic of vector database. In this video, I will walk you through a real demo. We will build a simple app, search with meaning, and even visualize how the AI understands your text behind the scenes. This is going to be fun, visual, and super easy to follow. So let's jump in. In this video, we are going to learn what is vector database and how it works, and what is the difference between traditional database and vector database, and I am going to do an implementation and demo on this. Let's start simple. What is a vector database? Imagine you are teaching a computer what is cat, mat and bat mean, but instead of using definitions, you give it in numbers, that is vectors, that represents how the word feel based on usage in real world language. A vector database stores these embeddings. The AI's understanding of your words and lets you search by meaning, not just by exact match. Each piece of data, that is text, image, and audio, etc., is converted into vector like this. For example, this is a cat, is numerically represented as 0.12 minus 0.84 and so on. This is how vector DB stores this value. Database is the heart of any application. Without database, no application can remember anything. Before we jump into vector database, let's take a quick look at what we have seen using so far. So SQL, NoSQL and time series are the traditional database we have been using till date. So SQL will store the structured tables. NoSQL database, we can store the unstructured data. In time series database, we store the IoT and sensor data. So how is a vector database different? Traditional database are great when you know exactly what to look for, but what if question is fuzzier? This is the exact difference between traditional and vector database. In traditional database, let's say find an apple. So if it is found in the database, I'm going to get the answer. Else, no record found. Then same query when I try to execute in the vector database, I'm going to get the apple if it is stored. Else, some other fruits like pears or fruit salad will be returned. Vector database works based on embedding and approximate nearest neighbors. Embedding is the brain of the database. Embeddings are like brain memory of a sentence. It means it is going to put a similar word close together. Approximate nearest neighbor finds item closest in vector space using hashing and graph-based techniques. Whether you want something fast for local development or enterprise scale for production, there are vector DB providers for every use case. Chroma, Pinecone, Weaviate, Phase, Quadrant. In our demo, we have used Chroma for our vector database. This is how I built a demo on vector database using a backend plus frontend. I built a tiny full stack project. The backend is powered by the FastAPI and ChromaDB. That is a powerful local vector database. The frontend is a clean React app and let us add sentence and search in real time. Then I added a Python script to visualize these vectors. Let's deep dive into a demo. So I have attached these programs in the description. Just download it and run the backend program. Use these commands to run the program. First I am creating a virtual environment for the Python. Then run this script. So once you execute this command to run that application, you will get the local host. So copy that local host and paste it in a browser. You can see that fast API. We are seeing that get and post as well as clearing the cache. Here I am executing the get all. Here you are seeing that these are the response we are going to get. Next I am running the npm start for the front end. Just opening in my separate browser, copying that one and just so vector db demo I have created the UI. Here I am going to add the cat. Using the backend API, you can see how this cat is stored as an embeddings. Now I am just searching the cat. You can see distance as 0.0. That is exact match. Next I am searching for mat. You can see the distance as 1.400. That is, it's just giving the nearest match for the mat as a cat. Now just run the 2D script. It will show how it is stored in vector database, both cat and mat are in different location. Now again go to that UI, add pat, and again search the cat. It is going to replace mat with the pat because the pat sound is matching with the cat. Again I'm searching pat, it's going to give pat and a cat. View it in the vector database. These cat, mat, pat are in the three different locations. Now I'm going to search Karthik. That is totally new. So it is returning pat and mat because Karthik word has sounds pat and cat. For John, same sound. Now I'm adding Karthik into the database and then again searching John. I'm getting Karthik as a search result because it is somewhat nearer. Both are names. Now searching Karthik, I'm getting Karthik and Pat. View it in the vector database. You can see all these four are saved in four different locations. Next, again I'm going to add a new name that is totally different from Karthik and John. That is, I'm going to add a name Ryan. So add it to the database and search Karthik. So you are going to get same Karthik and Pat, not Ryan. Now search for Ryan. So you'll get Ryan and a cat because the Karthik sound and Ryan sound is totally different. You can see Ryan is placed between the cat and Pat. That is the reason you are getting that result. Now I am going to add a dog into the database because we will see how cat and dog are positioned here. So go to the 2D script and you just run it. You can see this dog and cat are plotted in the same location while others are in the far away from these two, dog and cat. Now again I'm going to add another word, that is cow, because cow also comes under the same animal category. And let's see how it is plotted in the vector database. Again go and run that 2D program, and here you can see this cat, dog and cow are plotted almost near categories as a same thing. So yes, when you add a new word or sentence, vector stores as a new vector. So if you want to clear the database whatever we have stored, go to the backend program and clear the Chroma store. It will clear all the database whatever we have added as of now. So then again you run the program and you can go to that API link which I have created, and just hit on that get all API, and there you can see whether we are getting the same data or else we are going to get the empty one. Just I'm going to get all and executing that one. Here see everything is empty as of now. So till now, what did we build? A local vector database, a full stack app with add plus search, and a real-time embedding visualization. That's it guys. Thanks for watching. If you found this helpful, hit like, subscribe and let me know in the comments. I will see you in the next one, where we will build something even smarter using AI and code. Until then, stay curious. Bye bye.